Well, hello everyone, and welcome to a new video. In this video, we are going to talk about abstraction and interface. And by abstraction, let me just be specific. We're going to talk a bit about abstract classes, an abstract method. Before I say anything, I just want to tell you guys a little bit of a funny story that helped me a lot in my career. One day, and that was a long time ago, I applied for a job as a Java programmer. And they were looking for someone who knows how to write Java programs and have a experience that knows about Java. Back at that time, I knew Java, but I didn't know Java object-oriented programming style Java. Just the basics of Java. So I went to the interview, and they asked me about interface. And in this interface, when they asked me about interface questions, I didn't know what is the actual interface at that time. So my brain jumped into graphic user interface GUI, and I started talking about that. And then I left the interview thinking that I did a good impression. And then I immediately looked for a cafe where I can have an access to the internet to open my laptop and check what is that interface that they asked me about. And then I found out there was nothing correct about what I said in that interview. That's the moment where I realized I will never get a callback. So hopefully today you guys will understand interface, and when you're going to be asked about interface in interviews, you'll be able to answer correctly. The video today is going to be divided into two sections. We're going to talk about abstract methods, which is, in my opinion, the easy part. And interface is a little bit complicated and confusing, and I'm going to explain why is it confusing when we get to that point. The method that I'm going to use to explain those concepts, I'm going to start with examples, and then I'm going to jump into the syntax, and then I'm going to get into the details after that. So we'll start with abstract classes. Well, those are just the objectives. So again, well, you know what? I'm just going to switch it a little bit. Let's talk about some definitions, and then we'll get into examples. So what is an abstract class? Well, abstract classes are basically defined and declared as abstract. So you use the keyword abstract when you clear an abstract class. So that will be rule number one. Abstract classes may or may not have abstract methods, unlike C++. In C++, whenever you have an abstract method, which basically it's called virtual in C++, but the moment you have an abstract method in C++, that will automatically change the class to be an abstract class. Now, in Java, they made it a little bit easier. Basically, you decide if you want to have an abstract class or not by using the keyword abstract. So you can have an abstract class that doesn't have any abstract methods. But the moment you define an abstract method inside a class, that basically means that class will be automatically should be considered to be an abstract class, and you must use the abstract keyword. So this is rule number two. Rule number three, which is the most important rule, is whenever you create an abstract class, you cannot create objects out of that. Now you may ask the question, why is that? And again, with the examples, that will make it a lot easier to understand. Usually, abstract classes, or not usually, always, we use abstract classes as a superclass, so we inherit from them. And that's basically what we're going to be using. Those. Otherwise, it's going to be useless. If you create a class and you cannot create objects out of it, and you're not using it as a superclass, then basically you're not being able to use it at all. Abstract classes basically can have constructors and can have static methods normally. So those are the rules. Let me just repeat them again. Abstract classes has the keyword abstract. Abstract classes may or may not have abstract methods. You cannot create abstract objects, object out of abstract classes. And most importantly, you can only use them as a superclasses to inherit from and not anything else. And again, as I said, it may have static methods, it may have constructor, just like a regular class. Now let's move on to an example, and let's see, why do we need abstract classes? Now in this example, what do I have here? I have a class called animal, and I have other classes called dog and cat and cow. So Obviously, you can tell that we are going to have three subclasses that are going to inherit from the animal class, which is the cat and the dog and the animal. Now, I want you to imagine this. Imagine there is a method inside the animal class called make a sound or a sound. And that class basically will be connected to, that class basically, that method, sound method, basically will generate a sound on the speaker of your computer. So now I want you to think about that method. We have that method declared inside the animal class. Now, when you think about sound of dog, you can picture it and you can imagine it. When you think, and now I want you to do it in your mouth and you're in your mind. And then when I ask you to think about a cat sound, you can also imagine it. And then when we talk about the cow sound, you can imagine it. So dogs will woof woof, cats meow, and the cow moo. But I want you to, if I ask you this question, what is the animal sound? What is the animal sound? Can you answer that question and let me know if you have an answer for that? Again, an animal sound. A sound that's going to be generated by an animal. Can you answer that question? I'll tell you, you cannot. You cannot find an answer about what is the animal sound. And let me just tell you something also. There is no object called animal. You cannot, like, practically, theoretically, like when you go outside in the street, you point to something, you say, this is an animal. Yes, this is an animal, but it's not an animal, just an animal. That animal is a dog, it's a cat, it's a cow, it's a bat, it's a bird, it's a fish. It is something, but just to have an object as an animal and nothing else, that is that impossible. You cannot have an object as an animal. Animal here basically represent a perfect example of an abstract class. An abstract class that we use it in our life, we have in our life, but in reality you cannot see an object out of that class. So we use it usually for inheritance, just like we did here. We got a dog, we have a cat, we have a cow. All of them are animals. We know that. But again, a dog is a dog. You can characterize it as a dog. And there's a lot of features that makes a dog a dog. Same thing for the cat, same thing for the cow. But when it comes to the animal, you cannot have an object just by itself and you call it an animal. And this is here an example of what do we mean and why do we need abstract classes. And the sound method that I just asked you about is basically another example of what we call abstract methods. Because again, what is the sound of an animal? Again, you cannot find an answer for that. And if you can, let me know. So basically, the animal sound is a perfect method, example of an abstract method, and the animal class is also a perfect example of an abstract class. Let's go back to the it example that we had from the previous video. Now, it by itself, do you know what is it? Nobody knows what it is. What is it? Even Steve King doesn't know what is it. Or he did. Well, based on the movie that I watched, I didn't realize. I didn't understand what is it. But I understand the forms that it takes. So it could be treated as an abstract class because we don't know what it is. And we cannot create objects out of it, but we can create forms of it. And that's basically what we talked about last video. Also, if you think about a method called attack in it as an object. Now we know how Pennywise attack, we know how the women in the painting attack, we know how the leaper attack, or how they get people scared. But again, it by itself, we have no clue or no idea about how exactly that it object, if we can't create an object, will attack. So this is again another example of abstract classes. Now, to make it even easier to imagine and understand, let's take an example of situations where it's not going to be an abstract class. And let's go back to the example from the previous video. The Homer guy. Now, from the previous video we said, Homer is a man, and a man will be inherited by other classes like the husband, the father, the neighbor, and the employee. But again, if you think about it, Homer as a man, yeah, he could be an object in the street. You can walk in the street and you can see a man. There's nothing weird about that. But at the same time, you can see a husband, you can see a father, you can see a neighbor, you can see an employee out of that man. But at the same time, it is physically possible to see a man object in the street. Unlike an animal object that doesn't exist by itself, but a man, yes, we can see a man on the street. So those are the examples that I just wanted to use to explain the idea of abstraction. And then after that, we can move on into an example. I'm going to show you here in the slides, and then I'm going to go to the Eclipse. How do we create an abstract class? As you can see here, I created an abstract class I called a fruit, and you can see here, this is the keyword abstract. It's between the public and the class keyword. And you can see here that I created a lot of data members, and I do have a lot of functions as well. And here in the middle of this fruit function, I have a function called taste, and the taste will return a string, and I decided to create it as an abstract method. Now, an abstract class, all it needs is basically the keyword abstract to be written here. An abstract method, basically, you need to type the keyword abstract. That will be number one. Number two, you can see here at the end of the signature or the header of the method, I do have a semicolon. So let's define what is an abstract method. An abstract method basically is a method that doesn't have a body, just floating head. So, just signature. So an abstract method, again, we just explained that because we said abstract methods, basically we don't know exactly how, what is the implementation for it, just like when we talked about the sound of animal. So fruit, if I ask you the question, what is the taste of fruit? Well, it depends on the fruit itself. So you cannot have a clear answer about that, and that's why this is a perfect example of an abstract method. Just remember here, you put the keyword between the return data type and the specifier public in this case. And it must be public, by the way. Otherwise, if it's going to be private, then we'll see another rule we're going to explain in a sec. So as you can see here, I got public, I got the abstract keyword and I have string, and then there is no body. And remember, this is how do we declare and define an abstract method. Now, we have other methods. For example, I have an apple method and I have an avocado method. Now, for each one of those methods, as you can see here, to be able, just like we did with the regular inheritance, you're going to type extends fruit. Just as simple as that. Now, the most important rule when it comes to abstraction is that you must implement the abstract methods that you have from the abstract class. You see this method here, public abstract string test, and I want you to pay attention to this. Public string test, public string. Whenever you extend or you inherit from an abstract method, you must create, override the abstract methods in your new classes, the classes that inherit from that abstract class. Otherwise, if you don't do that, if you don't override those methods, your apple and avocado methods themselves are going to be treated as abstract classes. And when they are abstract classes, that basically means you cannot create objects out of them. So those are the rules that you have to understand. If you have an abstract class and you want to extend this abstract class, then if there is any abstract methods inside that abstract superclass, you must implement them inside your inheriting classes. Remember the rules, you don't have to put the keyword abstract anymore, of course, because otherwise that will convert it to an abstract, and this is not what we want. And it's just going to have the body, and as you can see here, the taste method for apple return, it's a little sour and bitter, but most sweet, not all salty, very juicy in general. And for the avocado, it's rich and mellow flavor with a thick, buttery texture. Now here's our main function, and if you want to create, and look at this, I'm just showing you this as an example. If you go ahead and try to create a fruit object, immediately you will get an error, and that error is going to tell you cannot instantiate a type fruit. Why is that? Because it's an abstract class. So what I did, I just use a polymorphism concept here. I create an array of two fruits, and then I reference them to two different objects. The first one is apple, and the second one is avocado. Okay, now before we go into the interface, let's move on to Eclipse. Nope, not you. And I do have it here somewhere. Yes. Let me close this. I'll get back to those in a sec. And here we go. We got the main class. We got the fruit. We got apple. And we got avocado. So let's move on to the fruit class. And in the fruit class, basically, I did a lot of code than the one that I have in the PowerPoint. So what did I have? What do I have here in the fruit? Well, every single fruit will have a price per pound. It will have a color and will have a type. What type of fruit do I have here? Okay, and now what do I have here? I have a default constructor and I have an argument constructor for the fruit. And for the default constructor, I'm setting everything to default values. And here I'm passing those variables as an arguments and receiving them in parameters. And then I'm using the setters to set those values. And this is actually the good practice to use the setters. And then I have toString method that will basically convert all these data into a string so I can use it whenever I want to print the object. And then here's my hero, a public abstract string test. As you can see here, I have the keyword abstract, I have a semicolon here, I don't have a body. The rest of this are just the setters and the getters that we know Eclipse will generate it for us with no problems. So let's go to the Apple class. In the Apple class, I decided to add a static final public string. I decided to call it class type, and it's going to be called Apple. And then here I do have an argument constructor, which basically going to receive the same exact values from the fruit. So you see those values here are going to be passed to the Apple project object. And here, what I'm doing in the body, I'm calling the constructor of fruit. So this is what's going to be implemented here. And then after that, I do have the test method implemented here, which is the whole point of the video. And then after I have the toString method, which basically is just going to add the class type to it. And I have the colon here, space, and then I have super toString. Right after that, I have the avocado, which basically will do the same. As you can see here, I got a class type avocado, and I have the constructor. We're basically going to do the same thing, and then I have the string test, and then I have the toString. Now the toString basically is very, very important here. I did have the class type here, which is avocado, and then that's not going to change, so that's why I'm going static final. And then I have the super.toString, so I'm calling the toString of the fruit. Now inside the main class, as you can see here, I showed you before, this is going to create those three classes, objects, and then after that I'm going to show them on the screen. And this is what I'm doing here. As you can see here, I'm calling the object f0, and then I'm calling the object f0.test. This will print at whatever f0 is, which is the toString method here. Where is it? And the second one will do the same thing, and most importantly, I want to call the method taste as well. So if I run it, you'll see the results down here. Apple type is gala, it's red, the price is 3.99 per pound, it's a little sour, blah blah blah. And then avocado, again, I don't know about avocado, I just googled it. So there's a type called Hass, it's a green, this is the price. I think, oh, this is way too much, I don't know, they sell them in pieces. It's rich, mellow, blah blah. So this is basically what abstract, and this is everything we need to understand. Now, before we move into interface, you need to have a clear understanding of abstract, because interface is somehow similar to abstract. Let's move on and start talking about interface. Now, what is an interface? Interface and abstract are related somehow when it comes to the syntax, but the application that we use for interface is different than the application we use for abstract. Now, before I start talking about interface, you need to understand something. Up until version 7 of Java, interface was defined at a certain way, and that definition was changed after version 8. I'm going to mention the main differences between them, but basically the applications that we use interface for, it's not any different. It's basically the same, but a lot has been added to the interface to a point you will start thinking about it that doesn't look like it's interface anymore. It looks like it's an abstract. Because again, what's the difference then between abstract and interface? You'll see that the differences are going to be really, really limited, like very, very small amount of differences between them. But again, just think about it. When it comes to the application, you need to understand when you're going to use interface and when you're going to use uh, abstract. So let's start with an example here. Again, this is not exactly how Java object-oriented programming works, but just to give you an idea about the difference between them, you can think about abstract as if your dad, for example, is planning to buy you a car and will let you decide about what kind of engine you're going to provide for your car. So everything will be done by your dad, and you'll be giving you're going to inherit that car, you're going to get it as it is, but you will be left with few other options that you can choose and you can customize. That's abstraction. When it comes to interface, the idea is a little bit different. Think about interface as the remote control you have for your TV, where you have a lot of buttons there. Those buttons are the interface that if you want to run that TV, then you have to understand and know how to use those buttons. That's basically what it is. You don't need to implement them by yourself, but you just need to understand how it works. Now, this example, I don't think it's really, really clear. There's an example provided by Oracle, which basically is the company that owns Java. You can go ahead to Oracle and have a look at it, but I'm just going to summarize what is that application or what is that example here. Imagine there's a manufacturer that makes cars, and now this manufacturer basically doesn't create the whole car. This manufacturer basically creates a car in general, and it's missing a lot of parts. Let's just put it that way. Now, a lot of other companies will come and buy that part at that level or at that situation, and they have a job to convert it to make it a fully functional car. Let's just put it that way. Now, when you buy that car, the original manufacturer that created the car that doesn't work would tell you, for you to be able to use our car, you need to find a way to make it move forward, move backward, turn left, turn right, start, and brake. Start the engine and brake the car. Brake and stop. So those are the main functionalities that you would need to be able to use that car. The manufacturer that created the car, before it starts selling it to people, will provide you with a list of operations that you, the buyer of that car, that month, must implement to be able to actually produce a car. That list is basically what we call an interface. Let me just go ahead and talk about another example. Well, before I get to that point, let's imagine you want to create, let's say you have a company, a network company, you want to come up with a new product, routers and switches, and all the other devices that network needs. Now, there are certain protocols that control the flow of data in a network. Those protocols or rules are important because we have a lot of different companies and they all produce those devices, and we need to make sure that all these devices can communicate. So there's a list of protocols, and for you to be able to manufacture and create a new device, you need to follow these rules. Well, that list of rules is basically what we mean by an interface. Those are the rules, those are the jobs, those are operations that your device must be able to implement for your device to be able to function in a real-life application. That's, again, an interface. I'll give you a third example. Let's imagine that you want to you want to create a graphic user interface. Now, the graphic user interface, basically, it's an application where you have, the mouse, the buttons, the frames, and all these kind of details. Now, that graphic user interface application has to do a lot with the operating system. So whenever you want to do that, you will have an interface that you have to implement, and that interface basically would tell you, for your application to be able to run on a Windows or whatever the operating system you have, this is a list of functions that you have no choices, but you have to implement. And that's basically what we mean by interface. I'm going to go into the syntax in a bit, but let's just go ahead and just read this. Imagine a futuristic society where computer controls robotic cars transport passengers through cities, streets without a human operator. The automobile manufacturer write a software that operates the automobile, stop, start, accelerate, turn left, turn right, and so forth. Another industrial group, electronic guidance instrument manufacturers make a computer system that receives, let's say, a GPS, position data, and write a transmission to traffic condition to use the information in driving that car. So here it is. The auto manufacturer must, again, this is it, must publish industry standard interface. And that interface basically will contain the details of what method that must be used to make that car move. Any car from that manufacturer. The guidance manufacturers can then write the software that invokes those, use those methods that described by the interface, so that the car can actually work. Now here's the bottom line here. Neither industrial group needs to know how the other group's software is implemented. In fact, each group is totally independent from the other one. But again, each one of them need to get the job done. That's the whole point of interface. So I'm going to go through some points about interface, and then we're going to go to the syntax. Interface is basically an abstract type. So here you can see that they're abstract type. And this abstract type basically specifies the behavior of that class must implement. Now I will put 100 lines under the word must. Basically means, and I will tell you, this is again the point of interface. You have your own class. When it's your class, you are free to do whatever you want to do with it. You are free to create the variables, methods, and everything. But when you implement an interface, that basically means you are having a list of operations that you have no control. You cannot avoid them. You cannot ignore them. You must implement them. So basically, that interface will force you to behave at a certain way. Interface is similar to protocols. We said that. And here we go. We're going to start talking about the syntax here. Interfaces are declared using the keyword interface. And I will put, again, you look at the word may, and may only contain method signatures and constant declarations. Now, up until version 7 of Java, the definition that the sentence here will be saying, interfaces are declared using interface keyword and only contain method signatures and constant declarations. After version 7, starting from after version 8, that changed. A lot more has been added to it. So, before version 7, interface used to be just declarations for constant variables and the signature of the method. The signature of the method basically is the method without a body, and it's basically very similar to abstract methods. So just have the signature of the body and with a semicolon. Now here's how start changing. All the methods of interface do not contain implementations, method bodies, all versions below Java 8. That's basically, and we're just repeating what I just said in the previous point. Now, starting from Java 8, default and static methods may have implementations in interface definition. So we start adding, as version 7, we had a default function, which is something you never heard about. Today we're going to talk about it. And static methods. We know what a static method is, but both of them were basically introduced in interface in version 8. In version 9, we start having private static methods in interface. So before version 7, it's just method signatures and declarations for final variables. Starting from version 8, we start having default, static, and private methods added. One of the most important things you should know about interfaces is that you cannot create objects out of interfaces, just like abstract classes. So you cannot have a method, sorry, you cannot have an object created using an interface. Now, here's the key here. This is one of the main benefits. And to be honest, I think this is the only benefits of using interfaces, if you will. One benefit of using interfaces is that you can actually have multiple inheritance. Now, let's go back to abstract and inheritance in general. You can only inherit from one class, but when it comes to implementation of interface, you can implement as much as you want. So this is, again, a very, very key factor, and I'm going to demonstrate all of that for you in a sec. So let's go ahead and look at the key features between abstract methods and interface methods. Now, I know this is a lot of talk and blah, 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 but I'm going to show you examples later to explain. So when it comes to variables, with interface, you can only have public and static and final variables. So that basically means you can only have constant variables. Now, when it comes to the syntax of that, just typing integer x equal 100, that basically means it's going to be public by default, and it's going to be static by default, and it's going to be final by default. So you don't have to type them, but if you just decided to type public, static, final, it's still going to be acceptable. Abstract, no. You can have private, public, protected, what, final, non-final, static, non-static, everything is available in abstract. So that's the most important difference. Inheritance and abstractions. Now, in inheritance, we said that we use the keyword implements to inherit, so to use the interface, sorry, and we use the abstract. With abstract, we use extends. Now, with inheritance, you can do multiple inheritance, and I'm going to show you that in a sec. But with abstraction, you can have only one extend class. When it comes to methods, this is where it gets a little bit confusing because there's a lot of details you have to understand. Now we're going to be talking about an interface. By default, everything is public. Unlike other classes, like abstract and abstract classes, everything by default is private. But with interfaces, everything by default is public. Now, those are one of the trick questions that you might be asked in an interface. In interface, we have an introduction to a new type of methods. It's called default method. Now, this is only available in interface. And again, default method acts exactly like non-abstract methods that has a body. So it's just like a regular method. You type default, that's the declaration for it inside the interface, and you'll have a method, and it will have a body. And again, when you get a use interface, that basically means you're going to inherit that interface, and you can use it if you want. Again, I'm moving forward to a point where interface is going to get really, really close to abstract. Private method. Now, from Java 9, private method has been added to interface. Now the question is that and again, it's not related to abstract or interface or just any class. What is the point of having a private method if you don't have access to it outside of that class? And the answer for that will be just for the inside use, internal use inside that class. Let's imagine you have an operation that you're going to be repeating it multiple times inside the class. Well, instead of repeating the code, just create a method for it, and you know that you're going to be using it inside the code only. So that's why the private was introduced. And again, a long time ago, we didn't have default methods, but now we do have default methods. So private methods and default methods will work together to help you there. But again, if you go back to the definition of interface from Java 7 all the way down, having a default method and a private method doesn't make any sense. Everything should be public, everything should be abstract and constant method variables. But since they added the default, after that they added the private back again just to make it work together. Again, doesn't mean that you have to use the default and private. I can guarantee that you find yourself ignoring them. And one of the things that I don't understand, most of the publishers of the book at a certain point refuse to accept the default and private methods. Like when I go back to books and even when they change the books and I look at the latest versions or editing of those books, they mention it, but they don't want to. They don't like to use the default private method. They just say, "We'll just stick with an interface. It's a list of methods that you must do. It's a to-do list, if you will." So here's the syntax. Now I'm going to show you the syntax here. I'm going to show you that in an Eclipse in a sec. But let's just go ahead and start with this. As you can see here, before I say anything, those names that I'm choosing is just for the demonstration. There's no purpose of this. So let's just go ahead here. So I got an interface, as you can see here. It's public, and I call it job. Why job? I don't know. It's just job. And you can see here, public final static string name job. This is equivalent to just type string name job. So this and this will work exactly the same. Now, what do I have here? I have another method called add. It's an integer, return an integer. It's called add, no arguments. And again, it has no body, so this is an abstract method. And look at it, public abstract. Again, this here, do you see down one here, integer add? It's exactly the same as this one. So I don't have to type them all. I just show you here that this is equivalent. Now, this is an example of a default method. Now, I want you to look at here. It's declared as default. It return an integer. I call it my add, and it's going to return 100 plus 200. Now, at Java 7 and before that, this is not acceptable for a lot of reasons. Reason number one, there wasn't a default declaration or specifier, and all the methods inside interface need to be abstract, so they should not have a body. That has been changed, so let's just put it that way. Now, I want you to remember this will act just like a public method. Now, I do have another interface here. This is one that's a little bit longer. I call it test, and in the test I declared a number 100, and I have 4 different methods here just to demonstrate. First of all, I have a private void my test, and then I got a static void your test, and again by default it's going to be public. And then I have private static, so this is a combination of those two together, void his test. All you can see here, all the methods are just going to test my test here, and then I have a default method here. Now look at the default method here. I am going to call the your test. Where is it? His test. Here's his test. It's private static, so I'm calling it using the name of the class, and then I'm using this, which is the object, my test, which is this one. So I'm calling this one and this one, those two methods. What is it? My test, here it is, that private one and the static one here, both together. I'm going to call this one later. And after that, return 100 plus 200, just like we did here. So those are my 2 interfaces. Now let's move on to the class that's going to implement those 2 interfaces. So I got interface job, interface test, and here it is. This is the syntax. Public class, my class, and implements, this is the keyword, and you list the classes you want to implement for them, test and job. And in this function, what I did basically, since I'm inheriting from the test method, let's go back to the test method, and the test method has an abstract method called add, then I have no options. I have to implement this add method. So I'm going to implement it here. And look what I have here. I have the return 7 plus 9. Now look at this. This my add. What is this my add? Let's go back and see what is my add. My add is this one. So you can see here is defined as default inside this interface, and I can call it outside of it. So this is a different class, and it's basically just acting like a public class. I do have access to it here. And also, I got test, your test, and let's go back and see what is your test here. Your test is this one, which is a static method. And if you go back here and see, I called it by using the, what do you call it, the name of the class test. And by default it's public, so I have no problem having access to it here using another class. And then after that, I just have the main method, and in the main method I created my class object. I called it the add method, which is basically this one. And then after that, I created a variable x, and then I said her test. Now, if you go here, what's her test? Her test is this method here, which is a default. Now look at this, it's a default. So it looks like a public, so you have access to it with no problems in this area. And this basically method will print those 2 messages and then return 300, and then I'm going to show the 300 on the screen. And that's basically what interface is. Now I'm going to go and show you the implementation of these methods in a sec. But before that, there are a few points that I think I should mention here before I continue to the end. First of all, I want you to think about this sentence. all the messages inside an interface must be abstract. And again, this is a question could be you could be asked about interviews. And again, in interviews, they focus on those small details. I will answer this question by yes, this is true if we're talking about Java 7 or before Java 7. Starting after Java 8, that's not the case anymore. So that would be the answer. Now, this is again one thing you should know. In UML, if you have an interface or abstract class, the name of the class must be italic. So if you've been given a UML and you look at the name of the class and you find it italic, that basically means that's an abstract or interface. And even with Eclipse, when you have an interface, you will see an I next to the name of the class. Interface out, this is important. This is extremely important here. An interface can extend number of interfaces using extend keyword. So if you have one interface and you want to include another interface into your interface, you can do that. You can have multiple interfaces inside your interface, but you're going to use the extends keyword. But again, if you want to extend, let's see, if you can extend one interface using the implement, and if you're going to use implements, you can actually have only one interface to be used. Integer versus integers. Well, int versus integers. This is something that's not really related to what we're talking about, but it's this is how it's built. So I'm just going to talk about it. Now we know what's an int, which is an integer. It's a primitive data type. Now there is an object. It's called integer, and object integer basically acts exactly the same as the regular integer, and we have a lot of more functionality to add to the integer object. One of them, it's to convert it from any different data types to another. You can convert it to a hexadecimal, decimal, to a string, and you can convert a string back to integer, and all these kind of functions. I would recommend to go and read about the integer object. And in addition to the integer object, we have a double object, we have a float object, we have a character. Every single primitive data type has an object of it, which basically adds a lot of more functionality to it. So this will be the end of this PowerPoint, and let's go ahead and have a look at the Eclipse. Now, just to save you time, I decided to type the code before I start the video to make, I don't want to make the video to last for 2 hours or something. So here we go. This is my interface, which I call it job, and I want you to look here. This is job, and you can see there's an I here. I don't know if the quality of the video will allow you to do that, but there's an I here. And this is my constant here, and this is my add method, which is an abstract method that doesn't have a body, and this is my default method. Now there's another interface, which is what I call test, still has another constant, and it has 3 different methods here: private, public static, private static, and a default. Inside this default, you can see here that I am calling this method here. I can do that here because it's private, so I can have access to it here with no problems. This one is private too, so I'm using it here. Look at the difference here. Since this one is static, so I'm using the name of the class, and since this one is not a static, so I'm using this keyword. And then after that, it's going to return the number 100 plus 200. Now inside the main class, not the main class, my class, I'm implementing both of those methods, as you can see here. And since test, as I said before, has an add abstract method, then I have to implement it here, and that's basically what I did. And in the implementation, I'm returning 7 plus 10, and then I'm doing this here, this dot my add. Now let's go back and see where's my add. My add is this one. It's part of this interface, and remember, it's a default, so it's just going to be acting as a public, and I have access to it here. Oh my god, my computer is acting up. Okay, here we go. So I do have access to that method. Again, this before Java 7 was not allowed. Now we do have abstract methods, so feel happy. And then after that, before that, actually I do have this your test, which basically is going to be implemented from the test class. And what is it called again? It's the your test. Now your test, as you can see here, it's a static, it's public, so because it's public, you have access to it outside of the class, and it's because it's static, I'm using the keyword test. It's not a keyword, actually, the name of the interface itself. Now here's my main method, and you can see here I'm creating all these objects. Now let me just run it. And okay, so the first thing you can see here that I created the object obj, and then I'm calling the function add. Now, if you go to my class and you call this add, you will see that there are two things are going to be. Where is it? Here it is. Yep. The first thing when you're going to run this is going to call this method test.yourTest, which basically is going to implement this one, so you can see that you got your test printed on screen. And then after that is going to return 7 plus 10 plus whatever this my method will add. So if you go to my add, which is this one, is going to return 300, and that's why I had 307. Now, after that, we do have, again, this example doesn't make any sense. It's just to show you the implementation and how does it work. And then I created an integer x, and I had the object itself, but this time I'm calling her test. Now, her test, if you think about it, there's no her test here. But since I'm implementing test file here, you can see that her test is, where is it? This is her test. Now, her test is, remember, it's public, it's default, and because it's default, that basically means you can have access to it with no problem. Now, when you go to the implementation of it inside, you see I'm calling this test, and test, his test, and this my test. This one is public, so no problem. This one is private. I can't call it with no problems because I'm implementing it inside this class, not outside. And then finally, it's going to return 300. So when I call the function here, at this point, it's going to show me his test, my test, and then after that, it's going to return the 300, and 300 is going to be printed, as you can see here. So this is basically what interface and abstraction is all about. Now, if I want to summarize this and take all these headache details away, I will say abstract is a class that in reality you cannot create objects out of them. It's a theoretical classes. It's a class that you know that there is an animal, but you don't see an object which is just an animal. That animal is something. It's a dog, it's a cat, it's an elephant, it's something, but it's not just an animal. You may think if you see something that you've never seen and nobody saw before, you think, oh, this is an animal. But again, after a while, you'll figure out a way to give it a name, and then after that, it's not going to be animal anymore. So whenever you have a case like that, that's where an abstract class will be really, really helpful. Now, abstract classes usually contain abstract methods, just like we said before. What is the test of a fruit? Well, you cannot tell. Sometimes they're sour, sometimes they're sweet. It depends on the type of the fruit. So this is a perfect example of an abstract method. What is the sound of an animal? Well, there's no sound of an animal. Every single animal has a different sound. Depends on the type of the animal. That's another example of abstraction or abstract classes. And then after that, we talked about interfaces. The easiest way to think about interface is basically if you have, let's say, a student and you want to draw a path for that student to success, tell the student this is a list of things that you have to do. I don't know how you're going to do them, but you must do them. If you manage to do them, then you will be success. That's how simple it is. So it's a way that we provide a list to other classes, and we control the behavior of these classes by forcing them to implement those methods. Why would I need that? Again, take that example of a car. You are creating, let's talk about this example here. I created a car. In this car, I have one of those smart screens. Now, this smart screen can run an Android or can run, let's say, the Mercedes company making the car. So that's system is owned by Mercedes, or we could go with Android or Apple. So what I'm going to do, I'm going to create an interface for that system that I have in that car, and I'm going to give a copy to each one of those companies. This is the interface, and the interface basically tells you that this system can implement the following operations. How exactly they're going to implement, I don't know. It's not my job. It's your job to figure it out. So if you want your product to be part of my product, then this is the list of the functions that your product must be able to implement for it to fit in my smart system that control my car. This will be the end of this lesson and this video, and I hope I'll see you guys later in new videos.